Hi, my name is Samir Mangalampalli. Today I'm going to talk about how we developed privacy preserving KPIs and features using Spark. We all know that privacy is hard, primarily because of regulations, compliance, data, discovering data, and lack of discovering data technologies and many other systems, right? So, and our goal was to help organizations understand how to use data uh, to get key measures that will help them achieve their strategic business goals. And these key measures that they were interested in could be like customer sentiment, or how to improve healthcare for um, maternity, for childbirth, or how to increase somebody's, how to predict my organization's revenue goals, whether I'm meeting my organization's revenue goals or not, right? Um, what we found in our journey is that data measures that are easy to obtain are not very useful many times, but measures that are useful are often very complicated to build. And these get even more complicated because of the privacy and security regulations or the governance problems that organizations face. Right? So our hypothesis is that we start off with using, if we start off with using privacy preserved data and provide these metrics and measures on top of that, then we are already way ahead of we are already able to overcome a lot of challenges, right? And hence we started on this journey, and this is what we're going to talk about now. So in this talk, I'm going to talk primarily in three parts. The first part is, where we started our journey, what kind of customer we started with, and how we evolved the product. The second part is going to talk about whatever we know about metric stores and feature stores and how we interpret it. And finally, our architecture, and then concluded with a demo, a quick demo. So let's start with our team, right? My team is mainly composed of myself and Neeru. He's a professor at Harvard Business School. And then we have a team of about 7 engineers plus 2 software engineers who support our applications. And Shashi is an instrument for marketing and other things that we do, right? So now, why did we go about building these KPIs, metrics, and features, right? So in our journey, the first customer that we had encountered had they were running a survey that was collecting about 10,000 surveys per day. And these particular surveys had a lot of PII data involved in them, and they needed to be HIPAA compliant and be secure and privacy preserving for all KPIs that they wanted to build. And the challenge is that the people who are handling this data were not very well versed with HIPAA or any other kind of GDPR or any other kind of law. And so they wanted some framework that could help them alleviate these concerns. So what kind of data did they collect? They collected, birth data, they collected your income level, age, they collected, how many times you are pregnant, what kind of food you feed your kids. So there was and these data was collected from primarily low income families. So they wanted to be extra careful. Our customers wanted to be extra careful with the data. So what was the business purpose or the main purpose of it, right? Is to improve healthcare for low income families, predict childbirth anomalies, understand trends in maternity cases, forecast the needs for their patients, how to help um, you know low income people think about nutrition or any of these things. they had to collect all this data, and they were trying to put together um, a set of analytics, reporting, and all the other aspects that could help them develop these meaningful insights. So what we decided is to start using something called metric stores and feature stores. Before we go into what these metric stores or feature stores are, let's understand what metrics are. Let's understand what features are and what KPIs are. Let's define it for our benefit, right? So metrics, I think, are like, I would call them as business as usual, right? But metrics are often used to track, monitor, and understand how your organization goals are progressing, right? Or how your applications are performing, or how what's happening with the data, just to understand it. Then features are something that we use to build meaningful insights, like for predictive machine learning model or descriptive models, or even prescriptive models. And then what are KPIs? What I interpret, or what we interpreted KPIs as, something is a combination of metrics and features that could be used to articulate insights, as well as help strategize goals, business goals, for organizations, and keep monitoring how they are performing. Right? That's the way I define KPIs, or we define KPIs at Cometrics. So what are metric stores? Right? Why do we need stores, and what are metric stores? I think there is quite a few of a lot of information out there on the internet, why stores and feature stores. But from our perspective, we define metrics as a shared piece of code that we could easily govern and can be shared across the organization and can be used in variety of functions, right? That's what we call metrics, and metrics within our metric store. And metric store is comprised of many of these metrics as code. Similarly, feature store is also built with the same idea, that we should be able to govern the data, protect it. And if you have code, or if you have some kind of a common representation, then it becomes easier to do it. That's why we picked feature stores as well. Now, what are the main advantages of stores themselves is because it then can act as a registry of, a body of registry. You can add who can access what, you can add a governance, you can add, security policies, you can add many aspects to it, and it could be easily become part of a shared infrastructure. And that's why we pick metric stores and feature stores. Now, metrics and KPIs are everywhere. I'm not going to have to spend too much time here, but I felt that it's good to just have that overview of what it is. An example of KPI is like, I have a specific strategic initiative to increase my net new income. So I would assume I would create a KPI like 15% growth in sales, versus a metric is something like, whether how often a user has come to the site, how often has he purchased a product, how many products are sold. All these are metrics. These metrics could be used to build the KPI, or it's a combination of metrics, or it could be a combination of metrics and features that could derive these KPIs. Now, what are the challenges that happen, right? In general, what in my experience, it's not easy to do these KPIs or metrics with data right, primarily because the complexity of the data ecosystem, right? There are many moving pieces, the types of technologies we pick, the cloud service provider that we pick, and the number of choices has become innumerable, right? And there needs to be some kind of a simplification, and there is a lot of new platforms that are coming up as of today, that will help alleviate this concern, right? Uh, our main concern, our main approach was that there are many data sets that cannot be brought into some other system. So we need to provide a way for users not to move their data out of their control and keep it within their control, but still be able to do the same, right? And that's one of the reasons why we started looking at this. The 7 to 8 steps typically takes about 2 to 6 months. Even in some cases, depends on your expertise that you have. It can take months before you actually see your data pipeline through. And even then, what I found after speaking to many customers is that it's very hard to keep it in a controlled fashion. There's always some mess. There's always things. But good news, with the rise of technologies, with the rise of things, there is always things that are getting easy, right? Now, the other side of the story is there are challenges to metrics, KPIs, and features. I'm pretty sure most of you are aware of these, but I'm just going to repeat it. Data strategies generally are hard in organizations, right? Because there are multiple stakeholders. Many people want different ways to look at the same data, or the same data coming up differently because of different access patterns. And oftentimes, to speed up things, people make copies of the same data, and if things are out of sync, you end up with different metrics, right? And this leads to another bottleneck, which is how you're going to manage the data. And on top of it, the whole pipeline setups are not easy. In our research, we found that small and medium enterprises are still struggling to do descriptive analytics in the right way, and they don't have the right expertise to do it. So to solve these problems, we have adopted a few techniques that were written. There were many privacy frameworks that were proposed in various papers, and there were many privacy algorithms like differential privacy and privacy techniques that came out through LinkedIn, Facebook, Apple, and many other research faculties. Primarily, we relied on OpenDP and Google's differential privacy, as well as a few other papers that we felt are appropriate. But the framework we chose is also a privacy preserving framework, which I'm going to show it as part of my references. We took this, we adopted data mesh and all these things, and came up with a unified framework that we feel will alleviate these problems in a much more seamless fashion, using Spark as a baseline architecture. And this framework was used to help build KPIs for our healthcare customer. So what were our objectives, right? When we started off, our main goal was we wanted to make sure that our customers got security, privacy, and data always compliant, so they are given, right? We always know that the people who produce the data or the people who own the data are the people who understand the data best, right? That's the second piece of information we went with. Using these two, we came up with a common infrastructure, and that enables powered by a unified data access pattern, right? And the goal is we encompass all the complexities of security, privacy, and governance into this ecosystem, and use data mesh patterns to be able to push the rules and everything in a decentralized fashion. So what are the things that we focused on, right? We focused primarily because our main customers were customers that had to work with API data, and SQL based, like mostly like Postgres, MySQL, SQL based databases that they had to work with. And there's a typo, we should have generalized it to those. And then we use the privacy frameworks to come up with a policy and a rule engine to be able to share data easily, and then come up with a data sharing agreement on top of cubes and rollups. Our premise, like I stated in a couple of slides earlier, is that we want to start with privacy preserving data, right? So how do we do that? What we did is we came up with a set of templates that say that given this context, this template, if you use this template, we can guarantee that privacy is available. And using that, those templates are, come up with counts, measures, top counts, cubes, rollups. We have even tried sentimental analysis. We have even come up with classification methods and clustering as these templates. And now we could potentially enable users to build cookbooks on top of these templates, right? And that's the framework and the features that we are supporting as part of this framework, as part of our platform. So how do we get from data to data-driven insights, right? This is very obvious to most people. This is Maslow's hierarchy of needs. So it's a standard process, and I believe that the slide is self-explanatory. But primarily, the key thing to note here is that we take the data, transform and protect before we learn or apply metrics. That way we can guarantee privacy and enable the right decisions. Now the accuracy of the data is not the same as running with a full data set, but that is something beyond the scope of this talk. So why did we pick Spark, right? Our main goal, like we said, was to enable self-service data platforms within your organization. So for which I think Spark was a no-brainer because of the simplicity that it's, and then has many connectors. It's a widely adopted open source community. It has a whole bunch of integrations for, and especially OpenDP and differential privacy Python libraries would easily fit in this. And we were able to leverage querying tools and Cube.js and all very easily on top of it. And of course, for any kind of a data processing system, scheduling and workflow management is essential. And Spark is a very well evolved system, so we picked Spark. So how does our architecture look like, right? Our architecture starts with step one. We have raw data. Then we know that the data owners understand the data. We empower them with sensitive data discovery tools that surfaces them a knowledge graph of all the things that are happening with the data. And then we let the users decide what kind of templates they want to do or what kind of analysis they feel that they want to perform today. And from there, you get cubes that have insights embedded with them that are exposed as either GraphQL, JDBC driver, or as a REST API that you could potentially use in your Jupyter notebooks or in business analytics reporting, or we could even export the data to Tableau or any of the things that we need. Primarily, our use cases were for in-app analytics, though. So what happens in our data discovery, right? We start with raw data. We run a cron job that runs every hour or so, depends on our customer. And then we sample the data. We have a hierarchy of rules first, and then we do a vectorized search that has about 250 PI elements within about 1,000 business entities that we have found we use. And that is our knowledge base. And using that, we identify, we provide all the relevant information necessary for that use, for that data set, that now you can intelligently apply templates, you can intelligently do whatever you need to do, like identity encryption or privacy or any other things, that k anonymity, all this could be achieved as part of this. And that's the main, that's the heart of our heart of our value proposition. Then from there, we allow, because we are now mapping these templates, this creates cookbooks, and these cookbooks are shared and deployed, and then you get the infrastructure running within your own cloud account or within your own on-prem account. And then these KPIs, metrics, and features are available for consumers to be able to consume the data. Here, I'm going to pause. I'm going to set up my demo, and I'm going to show you the demo for a minute. So thank you. In order to build privacy preserving KPIs, we need to know the privacy context first. And in order to know the privacy context, we perform a hierarchical approach. First, we look at the column names, column types. Then we do regex processing. Then we apply machine learning models. And then finally, a vectorized search that identifies the closest or nearest relatives to this data set. And using that, we discover and build a knowledge graph that you can use to be able to build this privacy preserving KPIs. Now, let me show you how that works. To present our use case, we start with a small database, which is a healthcare database that is sitting on PostgreSQL. Right? Now, this is a demo that we have set up for just for demonstration purposes, but it can be easily extended to other things. Now that the data source is configured, we import a bunch of tables that are there on that. And here is a survey table that we have created. It takes a few seconds for the knowledge graph to build. And then now you can go and start building a data sharing cookbook. What we call cookbooks are basically a set of measures, KPIs, and insights that you can put together in one document that gets executed at runtime. Now let's see. The first thing for anybody to start building data is to start sharing data, is to understand the vulnerabilities and risk and evaluation of, of the closest entities that are possible. And for that, let's call this cookbook pre-registration. Then we pick this data survey. This one will tell you all the PIIs, all the configuration, severity distribution based on that data set. Now what happens underneath, right? I'm going to demonstrate how we use Spark to be able to do that. And this could be, this basically takes a sample data set, does stratified sampling on the data, then sends it to pandas data frame, runs our machine learning models, and then the hierarchical steps, and then calls a vectorized search. Finally, gives you the result. Now this is running on my local machine, but this is also available on the cloud that we have. And this is based on several papers and several research accomplishments for which these references I have provided at the end. As we have talked about templates, so we offer templates here, and there is a bug in the UI. You can see that it's called categorical and numerical, but that's actually measures and dimensions. Initially, we started off with categorical and numerical, but now we have a better way to do this, which is measures and dimensions. And one of the things that we do is we provide these data set summaries. In here, what we can provide with this is a group distribution, or we provide conditional aggregations. And there is a, as you see, we can build the metrics, as you can see, or you're going to see that we can build queries and metrics on top of this, and then map them to templates, and finally get dashboards. Now, the first thing we have is age distribution, right? Age group. And I'm going to try to demonstrate the you can build this, and then you can map it to then you can map the columns, define the source type, and then add. And then you can preview. The main idea is that once you have these aggregates predefined, now we apply differential privacy on top of this and provide and build these metrics. And these metrics are available as Cube.js or as a feature store that you can later on use it for your pipelines, and you can use it for even dashboards or export it to Tableau or any other source. Now, the idea is that we're going to extend it to hundreds of templates. Right now, we have 10 to 20 templates that work. The idea is that we're going to extend it to hundreds of templates. Right now, we have 10 to 20 templates that work. And those templates are available for any of them. And these are running on Spark. And these templates are primarily SQL queries, as well as a few machine learning models that we have tested with, and that is to be able to extend it to others. And without Spark, we would not have been able to achieve this, because this would take, we would have to build a lot of in-house stuff. And we would. What have we learned? What we learned is that privacy-driven KPIs are not as hard as they were a few years back. There's been a tremendous amount of research that we could use to build privacy-aware KPIs. And Spark has been instrumental in making sure that we are able to deliver to our customer. We believe that privacy-aware metrics are going to be the future, and they will enable organizations even better than what was possible before. And hence, I want to thank everybody who's all the research that has been accomplished on this and has helped us get this far, right? And particularly, we have used heavily OpenDP, Airbnb, Duo. We have leveraged some of the learnings from Capital One Data Profiler. And then our framework is based on privacy preserving data sharing paper and many more references, right?